Imagine an engineer who never went to university, who taught himself mathematics by candlelight, and who designed the aircraft that saved Britain from destruction. The officials said his designs were too radical. The Air Ministry said his concepts were unsafe. But Sydney Cam didn't care what was considered impossible. He had lived through one world war already, and he knew the next one would be fought in the air. When German bombers threatened to cross the Channel, his creation, built in a small British factory, would become the nation's only defence. This is the story of the man who turned the Hurricane from an unapproved prototype into the fighter that decided the Battle of Britain and changed air warfare forever. Born in Windsor, England in 1893, Sydney Cam grew up fascinated by flight. At the time, the Wright brothers' first powered flight had taken place just a decade earlier, and aviation was still seen as a hobby for dreamers. Cam, the eldest of 12 children, couldn't afford formal higher education. Instead, he joined the Martinsyde Aircraft Company as an apprentice carpenter, absorbing every technical detail he could. By 1914, as the First World War broke out, Cam was already working with wood and fabric biplanes. He founded the Windsor Model Aeroplane Club, building gliders and models that showcased his early grasp of aerodynamics. His hands-on understanding of structure and stress would later become his greatest advantage. While others worked from theory, Cam built aircraft that actually held together under real-world strain. After the war, Martinsyde collapsed. Cam moved to the H.G. Hawker Engineering Company in Kingston upon Thames, a modest workshop trying to survive in the volatile post-war economy. Within a few years, he became its chief designer. Under his leadership, Hawker transformed from a small parts supplier into one of Britain's leading aircraft manufacturers. Cam believed in practical innovation. While many early aircraft engineers followed classical aerodynamics, he focused on building machines that pilots could rely on in combat. He combined elegance with brute function, a philosophy visible in every line of his later designs. In the 1920s, he worked on a succession of biplanes for the Royal Air Force, the Hart, the Fury, and the Audax. Each was faster, lighter, and more manoeuvrable than its predecessor. The Hart bomber, first flown in 1928, shocked the Air Ministry by outpacing the very fighters meant to intercept it. It became one of the RAF's main aircraft through the early 1930s. The success of these biplanes established Cam's reputation as a dependable, forward-thinking designer. Yet he could already see their limits. Biplanes relied on drag-heavy struts and wires. They could never reach the speeds modern warfare would require. By 1934, with tensions rising across Europe, Cam concluded that the next Great War would demand an all-metal monoplane fighter, something faster and more powerful than any British design to date. Cam began working on an experimental fighter that would combine the structural strength of steel tubing with the simplicity of fabric covering. It was designated the Hurricane, a name chosen to evoke speed and power. The Air Ministry, however, was cautious. The RAF's official program was already focused on a more advanced, all-metal monoplane being developed by Supermarine, the future Spitfire. Many officials saw no need for a second design. Cam argued that his approach could be produced faster and cheaper using existing manufacturing tools. His logic was simple. If war broke out soon, Britain wouldn't have time for expensive, complex fighters. He wanted something that could be mass-produced in hundreds, even thousands, without redesigning the entire industry. In November 1935, the prototype Hurricane K5083 made its first flight at Brooklands. It reached 315 miles per hour, impressive for a fabric-covered aircraft, and could outturn most fighters of its era. The Air Ministry approved a limited production order. It was a quiet success, almost overshadowed by the Spitfire's sleek metal form. But within a few years, the Hurricane would prove its worth in a way no one could ignore. As Europe drifted toward war in the late 1930s, Cam pushed his team relentlessly to refine the Hurricane's design. He replaced its wooden propeller with a variable pitch metal one, upgraded the engine to the Rolls-Royce Merlin, and strengthened the wings to mount 8.303 caliber Browning machine guns, the heaviest armament of any RAF fighter at that time. Many in the Air Ministry doubted the need for such firepower. Cam ignored them. He had watched reports of German air exercises and knew that future bombers would fly faster and higher than anything seen in the First World War. The Hurricane needed to deliver concentrated bursts of fire that could tear through heavy armour in seconds. By 1938, the aircraft entered full production. Hawker's assembly lines expanded rapidly, with subcontractors across Britain manufacturing components. The Hurricane became the RAF's first monoplane fighter to enter service, and by the outbreak of World War II in September 1939, over 500 were already operational. In the early months of the war, the Hurricane performed well against German bombers during the Battle of France. It was rugged, reliable, and easy to repair, a crucial advantage when operating from rough airfields under fire. However, as the Luftwaffe advanced, the RAF faced catastrophic losses. Many pilots barely escaped across the Channel. By mid-1940, Britain stood alone. The Luftwaffe prepared to annihilate the RAF as a prelude to invasion. At this moment, the Hurricane would become the unsung backbone of the defence. Out of 1,963 RAF fighters available at the start of the Battle of Britain, roughly 2/3 were Hurricanes. They were slower than the Spitfire, but more stable and easier to control in a dogfight. The Hurricane's thick wings could absorb damage that would destroy lighter aircraft. In combat, pilots quickly learned to let the Spitfires take on enemy fighters, while the Hurricanes went after bombers. A tactical pairing that defined the battle's outcome. By September 1940, the Hurricane had destroyed more enemy aircraft than all other British defences combined. Its design, conceived in a small Kingston workshop, became a national symbol of endurance. And behind that design stood a man who never sought fame. A self-taught engineer who believed function mattered more than elegance. As bombs fell over London and British pilots fought for survival, Sidney Cam continued working, sketching improved versions of the Hurricane even as sirens wailed outside his factory. He wasn't satisfied with saving Britain once. He wanted to build something even faster. By the spring of 1941, the Hurricane's days as Britain's premier fighter were numbered. New German aircraft like the Messerschmitt Bf 109F and the Focke-Wulf 190 outclimbed, outdove and outfought the older British machines. Sidney Cam knew the balance of air power was shifting. The same qualities that had made the Hurricane reliable, its thick wings, fabric skin and simple framework, now limited its speed and altitude. Cam realised that if Britain was to survive another air war, the next aircraft had to be faster, stronger and built entirely of metal. The Air Ministry wanted a successor, but opinions were divided. Some argued for refinement of existing designs, others insisted on starting from scratch. Cam preferred evolution over revolution. He believed that the Hurricane's basic structure could be adapted to handle a much larger engine. At Hawker's Kingston factory, Cam began designing an interceptor around the Napier Sabre, an experimental 24-cylinder engine capable of delivering more than 2,000 horsepower. The project was named the Typhoon, and on paper it promised speeds above 400 miles per hour. But translating that into an aircraft that could actually fly was another matter. The Sabre's cooling system was complex and prone to failure. Early prototypes suffered tail vibrations and structural weaknesses. On one test flight in 1940, pilot Philip Lucas narrowly survived when the tail of his Typhoon began tearing apart in the air. He managed to land the plane despite severe damage. Lucas's survival provided the data engineers needed to reinforce the design, but the Air Ministry's confidence was shaken. The Typhoon was intended as a high-altitude interceptor, yet its thick wings caused severe drag above 20,000 feet. Enemy bombers often flew higher than that, making interception impossible. Cam, however, saw potential where others saw failure. The Typhoon's great strength was its power at low altitude. It accelerated faster than any Allied fighter near the ground, making it ideal for countering German Focke-Wulf 190s that attacked at treetop height. Cam argued to keep the program alive, convinced that the aircraft could fill a different role. By 1942, his persistence paid off. The Royal Air Force began deploying Typhoons for ground attack missions along the Channel coast, where their speed and heavy armament proved decisive. Cam's design philosophy had always been practical. Adapt to the conditions, not the expectations. The Typhoon carried 4 20mm Hispano cannons and could be fitted with rockets or bombs under the wings. These modifications turned it into one of the most destructive low-level strike aircraft of the war. When the Allies launched the Normandy invasion in June 1944, the Typhoon was the spearhead of the 2nd Tactical Air Force. Pilots flew in pairs, skimming fields and hedgerows, striking German tanks and convoys before they reached the front. Their rocket salvos shredded armor columns. No Allied ground gun could stop. Reports from France described retreating troops abandoning vehicles at the mere sight of the Typhoon's silhouette overhead. Even with its success, Cam was never satisfied. He considered the Typhoon an interim step, too heavy, too drag-bound and limited in altitude. He and his team began redesigning the airframe to solve these problems. The result was the Tempest, a refined evolution with a thinner elliptical wing, longer fuselage and higher top speed. Cam personally oversaw the redesign in 1942 and 1943, pushing his engineers to combine power with aerodynamic efficiency. The Air Ministry again hesitated. Production lines were already stretched, and Britain's resources were under strain. But Hawker's track record gave them leverage. By early 1944, the Tempest was ready for combat. The first Tempests joined operations just as the Germans began launching V-1 flying bombs against London. The RAF needed an aircraft fast enough to catch these pilotless missiles, which travelled at more than 400 miles per hour. Most fighters were too slow. The Tempest, with its powerful Napier Sabre II engine, could dive at nearly 500 miles per hour and maintain level flight above 430. Pilots learned to approach from behind and flip the bomb's wings using their own wingtips, causing the V-1 to crash before reaching the city. Between June and August 1944, Tempest squadrons destroyed more than 600 of the weapons. Cam's latest design had once again arrived at the exact moment Britain needed it most. Behind the front lines, he was already thinking ahead. Jet propulsion had moved from theory to practice. Frank Whittle's early turbojets had shown promise, and the Germans had introduced the Messerschmitt Me-262 jet fighter. Cam knew that the era of propellers was ending, yet he also believed that piston engines still had untapped potential. While engineers debated the future, he insisted Hawker must master both technologies. The company continued refining the Tempest while beginning preliminary studies for jet aircraft. Cam's management style remained relentless. Colleagues described him as precise to the point of intimidation. He expected engineers to present solutions, not problems. Meetings were short and direct. His authority came not from titles but from competence. He could calculate stress loads and aerodynamic coefficients in his head. During one design session, when an engineer argued that a modification was impossible, Cam simply replied, "Nothing is impossible. It just hasn't been done yet." That attitude, more than any specific formula, defined Hawker's post-war success. By 1945, the Tempest had become one of the fastest piston engine fighters in the world. It was used to intercept the few remaining German jets as they took off or landed, exploiting their slow acceleration. It also performed ground attacks across occupied Europe, crippling retreating enemy forces in the closing months of the war. In one of its final missions, a Tempest squadron shot down the last German aircraft destroyed over Western Europe before the armistice. When peace came, the RAF's pilots regarded the Typhoon and Tempest not merely as machines, but as symbols of survival. Aircraft that could take punishment, deliver precision, and return home. For Sidney Cam, the end of the war marked both an achievement and a challenge. The world owed much of its freedom to air power, and his designs had played a crucial role in that outcome. Yet the rapid pace of innovation meant there was no time for reflection. The jet age had already begun, and Hawker would have to adapt or become irrelevant. Cam was 62 years old when the war ended, but his ambition remained unbroken. His next task would be to lead Britain into a new technological frontier, where the very definition of flight was about to change. By the late 1940s, Britain's aircraft industry stood at a crossroads. The Second World War had proven the dominance of air power, but the rapid shift toward jet propulsion threatened to render entire factories obsolete overnight. The Royal Air Force was transitioning from piston engines to jets, and the race to produce faster, higher-flying fighters was underway across the world. For Sidney Cam, this transition wasn't just a technical challenge, it was a question of survival for Hawker itself. The company had relied on his designs for 2 decades. Now he needed to reinvent everything he knew about flight. Cam approached the jet age with his characteristic practicality. He was not interested in chasing theoretical perfection. He wanted a fighter that could be built, maintained, and flown by real squadrons. In 1947, his team began development of what would become the Hawker P-1067, later known as the Hawker Hunter. It was to be powered by the Rolls-Royce Avon turbojet, a new generation of British engines offering higher thrust and efficiency than anything before. Cam understood that aerodynamics would define success in this new era. He prioritized clean lines, a thin swept wing, and minimal drag, concepts that were still experimental for British designers. The first prototype took shape at Hawker's Kingston plant in 1950. Cam insisted on using conventional materials and methods wherever possible, believing that advanced design didn't require untested production techniques. The prototype's flight in July 1951 validated his confidence. Test pilot Neville Duke reported exceptional handling, high stability, and smooth acceleration past 600 miles per hour. The Air Ministry quickly recognized the aircraft's potential. What began as an internal project became the cornerstone of Britain's new jet defense program. Yet progress was never easy. The Hunter suffered from several growing pains common to first-generation jet fighters. Early production models experienced fuel starvation during dives, gun gas ingestion into the engine when firing cannons, and limited endurance due to small internal fuel tanks. Each issue required redesigns that delayed deployment. Cam refused to rush production, arguing that precision mattered more than publicity. His approach frustrated some officials, but it preserved the aircraft's long-term reliability. When the Hunter entered service in 1954, it was immediately recognized as one of the most capable jet fighters in the world. Its performance surpassed most of its contemporaries, combining high speed with remarkable maneuverability. Pilots described it as an aircraft that flew like a dream, balanced, responsive, and forgiving. The Hunter set multiple world speed records, including a record of 727.63 miles per hour achieved by Neville Duke in 1953. For Cam, these records were less important than the aircraft's practicality. The Hunter could be mass-produced, maintained easily, and adapted for multiple roles: interceptor, ground attack, reconnaissance. It became a mainstay of the RAF and was exported to over 20 nations. While Britain's political climate grew uncertain, Cam continued to innovate. The Cold War was intensifying, and defense budgets fluctuated between expansion and austerity. Many designers turned toward futuristic, delta-wing concepts. Cam, however, believed in incremental evolution. His philosophy remained rooted in function. Every line, rivet, and panel had to serve a clear aerodynamic or structural purpose. In meetings, he often dismissed overly ambitious proposals with a single phrase: "Too clever by half." He respected engineering realism above all else. As jet fighters evolved, Cam's attention shifted toward solving one of aviation's oldest challenges: the dependence on long runways. The emergence of tactical nuclear weapons made airbases vulnerable targets. If Britain's runways were destroyed, its air defense could collapse within hours. Cam envisioned a fighter that could take off and land vertically, operating from small clearings or damaged airfields. It was an idea that had been discussed for decades but dismissed as impractical. Cam believed the technology was finally close to making it possible. In 1957, the Hawker team began work on a radical experimental aircraft known as the P-1127. It would use a single Bristol Siddeley Pegasus engine, capable of vectoring its thrust, directing the jet exhaust downward for lift or backward for forward flight. The concept of vectored thrust was entirely new. It required precise engineering of the nozzles, control systems, and airframe balance. Many within the industry doubted it could be done, but Cam, as always, pushed forward quietly. He delegated much of the detailed design work to Ralph Hooper, a talented engineer under his supervision, while providing overall direction and ensuring that every step aligned with Hawker's design discipline. The first P-1127 prototype flew in 1960, initially tethered to the ground during vertical tests. It hovered successfully, then transitioned to forward flight, a feat no British aircraft had achieved before. The success astonished both the RAF and NATO observers. The project attracted international attention, especially from the United States, which funded further development under a joint evaluation program. What began as a small experimental project in Kingston evolved into the Hawker Harrier, the world's first operational vertical short takeoff and landing (VSTOL) fighter. Cam's contribution to the Harrier's success went beyond design oversight. He had created a culture at Hawker where innovation was grounded in practicality. Engineers were encouraged to experiment, but every experiment had to serve a strategic purpose. His experience from decades of aircraft evolution gave him a unique perspective. He could see connections between the wooden biplanes of the 1920s and the jet-powered machines of the 1960s. To him, progress was continuous, not revolutionary. During these years, Cam also became a senior figure in Britain's aeronautical establishment. He served on the Air Registration Board, advised on government projects, and mentored younger designers who would later shape the British aerospace industry. Despite his influence, he remained a private man. Those who worked with him said he cared little for ceremony or recognition. He preferred workshop floors to offices and often spent evenings sketching new design ideas by hand. The Hunter and Harrier cemented Cam's place in aviation history. Together, they represented the full arc of technological evolution, from the piston-driven Hurricane that fought over Britain to the jet that could lift off vertically. He had guided one company, and arguably one nation, through the most transformative period in the history of flight. Yet he never described himself as a visionary. When asked how he achieved so much without formal engineering education, he answered simply, "I learnt by doing." By the early 1960s, Hawker had merged with other firms to form Hawker Siddeley Aviation, part of Britain's broader effort to consolidate its aerospace industry. Cam accepted the changes but missed the smaller, more personal environment of the old Hawker company. He continued as chief designer until his retirement in 1965, overseeing the final development stages of the Harrier. Even in his last years at the firm, he remained sharp and direct. One engineer recalled presenting a complex aerodynamic report to him. Cam listened silently, then pointed at a single equation and said, "That's wrong, and if that's wrong, the whole thing is useless." When they checked the numbers later, he was right. As retirement approached, Cam reflected little on fame or legacy. His satisfaction came from seeing pilots trust his aircraft. The Hurricane had defended Britain. The Typhoon and Tempest had crushed German armour. The Hunter had carried the RAF through the jet age. The Harrier, still experimental at the time, promised to redefine aerial combat once more. For over 40 years, every major step in British fighter design bore his influence. He retired quietly, leaving behind one of the most extraordinary design records in aviation. Yet his work would continue to shape military technology long after he was gone. The Harrier entered full service after his departure, becoming an icon of engineering ingenuity, a fitting tribute to a man who believed that no design problem was beyond solution. When Sidney Cam left Hawker Siddeley in 1965, he did so without ceremony. There were no speeches or documentaries about his achievements, no public celebrations of the man who had designed more combat aircraft than anyone else in British history. He stepped away from the industry quietly, just as he had worked throughout his life, focused on results, not recognition. But his departure marked the end of an era. The company he had helped build from a small post-war workshop into one of the world's foremost aircraft manufacturers was now a cornerstone of Britain's aerospace identity. His final project, the P1127, was undergoing its final transformation into the Harrier, the world's first operational vertical takeoff fighter. Cam remained a consultant for a time, offering his opinion on engineering proposals and government reports. Though officially retired, he continued to visit the Kingston factory on occasion, walking through the design office where younger engineers still kept his old drafting table untouched. Many of them had learned directly from him. His precision, his intolerance for vague reasoning, his ability to see flaws in a drawing at a glance. Even in retirement, his reputation was enough to keep standards high. He once remarked to a colleague that he didn't miss the deadlines or the politics, but he did miss the smell of metal and fuel. In the mid-1960s, Britain's aerospace industry was consolidating further, merging companies and reducing competition in an effort to manage costs. Cam was sceptical of these changes. He believed innovation thrived in small, independent teams that could move fast and take risks. Yet he also understood that the new political and economic climate left little choice. Defence budgets were shrinking, and the golden age of aircraft design, the period he had dominated, was ending. The new generation of engineers relied increasingly on computers, wind tunnels, and automated calculations. Cam had always designed by instinct and mathematics scribbled on notepads, but he respected the shift. "Tools change," he once said, "but the laws of flight never do." Outside the workshop, he lived a modest life. He and his wife Hilda remained in Kingston, where he occasionally gave talks to local aeronautical societies. He disliked publicity, but agreed to a few interviews in which he discussed the evolution of aircraft design from the wooden biplanes of his youth to the jet fighters of the Cold War. He spoke plainly, with none of the dramatisation that others attached to his story. When asked what had motivated him through 40 years of design, he replied, "I didn't care for glory. I cared that the pilot came back alive." By the time he reached his 70s, his influence was visible everywhere. The Royal Air Force still relied on the Hunter, which served in conflicts from the Middle East to Southeast Asia. The Tempest and Typhoon, once central to the European front, were now museum pieces, symbols of resilience. And the Harrier, his final contribution, was entering production, soon to demonstrate its worth in ways even he might not have predicted. Cam followed its progress closely, often reading test reports and sending handwritten notes to his former colleagues with small technical suggestions. They still referred to him simply as Mr. Cam, a sign of respect that never faded. Recognition finally came late. In 1953, he had been knighted for his wartime contributions, an honour he accepted reluctantly. Later, universities that once would not have admitted him awarded him honorary degrees. He became a Fellow of the Royal Aeronautical Society and received the Gold Medal of the Royal Society of Arts. But those who knew him best said he valued none of these distinctions as much as the satisfaction of a clean test flight report. He judged success by the aircraft, not the applause. In 1966, just a year after his retirement, Sydney Cam passed away at the age of 72. The news barely reached the public. Only later did aviation journals begin to recount the scale of his influence. Colleagues described his death as the closing of the book on the age of the individual designer. The world of aviation had grown too large, too complex for single figures to dominate. But Cam had belonged to a different time, a time when one person's judgment could shape the fate of nations. In the decades that followed, every new generation of engineers rediscovered his work. The Hurricane became an enduring national symbol, its simple, rugged lines reminding Britain of a moment when survival depended on ingenuity. The Typhoon and Tempest were studied for their aerodynamics and structural design. The Hunter remained in active service around the world until the 1990s, an unmatched record for a post-war fighter. And the Harrier, the ultimate expression of his design philosophy, would prove itself in conflicts across the late 20th century. From the Falklands to the Gulf. Its ability to take off and land vertically fulfilled the vision he had pursued since the 1950s, the dream of complete independence from runways, of aircraft that could operate anywhere. Historians often call Sydney Cam the designer who saved Britain. The phrase is not an exaggeration. Without the Hurricane, the Royal Air Force might not have survived the Battle of Britain. Without his relentless pursuit of performance and practicality, British aviation might not have adapted quickly enough to the jet age. Cam's genius lay not in abstract theory, but in his method, precise, disciplined, and grounded in reality. He trusted materials, data, and pilot feedback over politics or speculation. Where others sought elegance, he sought efficiency. Where others hesitated, he built. In the engineering community, his legacy became a benchmark. Designers studying the transition from wood to metal, from propeller to jet, traced the logic of each step back to Cam's workshop. His drawings revealed a deep respect for simplicity. Straight lines, accessible maintenance points, components designed for mass production. He believed complexity was the enemy of reliability, a principle that guided every project from the Fury biplane to the Harrier. Modern aerospace firms still reference his approach in design methodology courses, teaching students that innovation must always serve function. The values he embodied, clarity, persistence, and responsibility, shaped generations of British engineers. They learned from him that technical brilliance meant little without purpose. His career spanned the rise of powered flight, 2 world wars, and the dawn of supersonic aviation, yet his focus never changed. Every design was built around one central idea: give the pilot the best possible chance to survive and succeed. Today, the aircraft that carry his name stand as monuments to that philosophy. At the Royal Air Force Museum in London, the Hurricane still bears the marks of its rivets and repairs, a reminder that perfection in design isn't about smooth surfaces, but about strength where it matters most. Nearby, a Hawker Hunter gleams beneath spotlights, its swept wings capturing the grace of post-war engineering. And at Duxford, a Harrier hangs suspended from the ceiling, a symbol of innovation that grew from the determination of a man who began as a carpenter's apprentice in Windsor. Sidney Cam never sought to be remembered as a hero. He saw himself as an engineer, nothing more. Yet history remembers him differently. His work bridged every major shift in aviation across half a century. He built machines that fought, protected, and inspired. And even decades after his death, the principles he stood for, precision, practicality, and the refusal to accept limits, continue to guide those who build the aircraft of the future. His story is not one of sudden genius or dramatic discovery. It is the story of endurance, of an ordinary man who redefined what could be achieved through skill, discipline, and relentless attention to detail.